What is up, guys? This is Florida Man Does Weather. We are back with a very special video. Today we are featuring Dr. Sam Perugini. This is the man when it comes to tropical meteorology and really all things meteorology. We both had classes with him. We really like this guy. He knows his stuff. So let's get into it. Right now on this map, I got the Saharan air layer pulled up, and there's been a lot of buzz going around on social media. A lot of these hype pages are talking about how we are virtually guaranteed to have a Gulf system come out of the Central American Gyre in about a week. And all this dust says otherwise, I think.
Yeah, well, that's a good question because this dust moves. I mean, we see these dust clouds, if you will, multiple times in a hurricane season. And when they're moving through, it really does put a lid on tropical development because if you think about where this air came from, I mean, it is an air mass, right? It originated over the Sahara. So it is a hot and it is a dry air mass, right? But yet it manifests itself in the mid and upper levels of the atmosphere. There's a lot of dust involved with it. And one of the things that helps us to understand what it does to the tropical atmosphere in terms of putting the lid on tropical development is to take a look at a sounding that goes on underneath the Saharan air layer. So I'm going to share my screen here, and we're going to do multiple. I think I set it up for multiple,
Yep.
and I don't want to look at that. But what we're going to look at here is a sounding courtesy of our friends at the University of Wyoming, and this is a sounding from 12Z today, that being Tuesday, the 3rd of June, from San Juan, Puerto Rico, right? Which on the previous map showing the dust cloud, if you will, is right underneath it. And one of the things that you notice is that inversion that is occurring between, just above the 800 millibar layer. And note how dry the atmosphere is. Here's the dew point on the sounding all the way up to a very deep layer in the atmosphere. And so one of the hallmarks of the SAL, if you will, is very, very dry air. Now, it is very typical to see this type of an inversion in the tropics, the trade wind inversion, if you will. But when you get the SAL involved, when you get these bursts, you really have a very, very dry atmosphere. And I mean, you can see what the partial path on this looks like, and it's got a lot of work to do in order to reach the level of free convection. And it just, yeah, you get some pop-up stuff, but you're not going to see a tropical storm developing. So as that air mass propagates westward and the deep easterly flow in the low and mid levels of the atmosphere, it's going to be putting a lid on things, at least in the short term. But that doesn't mean that things will change. If you're looking 10 days down the road, this air mass is going to be kind of out of the way by then.
Mhm. So I know that this specific Saharan dust is forecast to pretty much enter the Western Caribbean and then kind of recurve back around
In the
on
Gulf of
the
Mexico.
edge of this high pressure
Yeah.
and basically shoot itself out this way and then kind of over here. And then you've got this
Go
other
back and
gap
forth.
behind it. And that's where I think that's where the window is for something to maybe develop. But still, even that's a huge maybe. You've got the GFS ensembles are absolutely going insane in that area, but this is just what they've been doing for week after week at this point. You've got this one area. This is already designated I believe, a 70% chance of development by the National Hurricane Center, and it's showing up on multiple different model ensemble runs. The Euro's got this showing up. I believe the Icon also starting to have inklings of tropical development as far as it goes out. But that's really the only thing. And then you've got that little 10%er up here in the Carolinas. But then once we get out to, let's say, 180 hours, that's when the GFS ensembles just go insane and put tropical storms, hurricanes pretty much everywhere.
Everywhere.
What do we think on that? Because personally, hour 264, this is the comedy hour. Why does it do this?
Well, for one, you have to keep in mind what the ensemble is, right? It's multiple runs of the same model with little tweaks, right? So when you take a look at the individual pressure centers, they're all over the place. But I think you can clearly see that there is an area here from the Western Caribbean into the Gulf of America and off the west coast of Mexico. Forget the land masses for a second, right? Where it wants to develop something,
Hmm.
right? It's
Right.
almost insistent on developing something. So what that tells me when you're looking out this far is it's sniffing something out in the overall pattern. And if it is, well, what is that overall pattern? And does it make sense? Like, for example, it could have all sorts of storms, but if its overall synoptic pattern, the large scale pattern, doesn't really is not really conducive for that, you really take it with a grain of salt. If it dovetails with what the overall synoptic pattern is, then you may want to pay more attention. Because sometimes, I mean, the GFS I've noticed, and I notice this with a lot of times with East Coast cyclogenesis in the winter season, that it convects its little heart out over the Gulf
Yeah.
Stream, and it
Right.
artificially lowers the pressure too far east, so the low is too far east, and it has the low 10 days out, it looks perfect, and then it gets cold feet days 5 to 7 out, and then it brings it back because it has this, right. So if it's not fitting the pattern, perhaps it's a convective feedback thing. It doesn't mean it can't happen, right? But something like this tells me that it is sniffing something out. And I'm going to show you what I think that might be. So let me
We got the
share my screen
MJL.
here. And I'm going to pull up another map. And this map is courtesy of our friends at Weatherbell. Now, here we are looking at the world. And if you want to, pick out what we're looking at here, here is, North America, right? And here's South America, Central America, and here's the western part of North America, right? So just to kind of orient yourself here. And we're looking at greens and browns. So what do they mean? Well, if you take a look at what the key is, right, this is what is called the chi anomaly. Oh boy, that sounds scary and it sounds like dynamics, doesn't it? It's the 200 millibar divergent wind and velocity potential anomaly, right? And without getting into the gory details of what that is, here's the way to look at it. When you're looking at 200 millibars on a map like this, the brown areas are areas of convergence at 200 millibars. And the green areas are areas of divergence at 200 millibars.
Hmm.
So if you're having convergence at 200 millibars, right, if you just think of the simple three-dimensional circulation, the air comes together, 200, it sinks, spreads out at the surface, you're not going to be convecting substantially. If it's divergent at 200 millibars, well, then that is general rising motion in the atmosphere that helps support the development. And we watched this all last season. If you take a look at what happened last September across the Atlantic, it was as brown can be, and it no matter what the model. Oh, look, it has something. It did, and nothing happened because you had large scale subsidence. Now, this is the 264-hour GFS, so we're looking at the end of next week. And note the area of neutral to divergent air at 200 millibars. It extends from Central America across the Western Caribbean, Gulf of America, out into the Atlantic Ocean, the Western
Hmm.
Atlantic. That is conducive for general rising motion. That is conducive, and we're going to start simple, for convection, right? For sustainable convection, just based upon the airflow at 200 millibars. If the air was sinking, it's really tough to do it. In fact, I've seen on how many times where you have hurricanes that, go to town off the coast of Africa, and they're heading across and they're moving into an area of large scale subsidence, and they do the collapsomatic,
Hmm.
and
They
they
just
just
fall
kind
apart.
of
Yeah.
fall apart. And right, so that is it. Now, I think what we can do is if we can follow this over time, and let's turn back the clock to today, and notice where we are today, right? If you take a look across the entire tropical Atlantic, right, you've got large scale subsidence that is occurring right now,
Yeah.
right?
They only
And
for areas over Florida.
Yeah, it is, and it's neutral,
Right.
right? And if you take a look here out in the Western Pacific,
That's where all
hmm
the storms are.
that's right. Look at that, right? And this is, and we're not going to get into the nitty gritty of this today,
Right.
but one of the things to look at when you're doing medium range tropical cyclone forecasting, right, is taking a look at where you have these divergent and convergent, which are related to the phase of the Madden-Julian oscillation, right? That's another topic for another day. But right now, right, you can see where, you would generally find upward motion over there, downward motion here. You can see how separated they are,
hmm
right? In fact, this downward extends all the way across Africa, across the Indian Ocean.
Large scale.
Now, as we go through time, yeah, on the large scale. So as we go through time, and let's go ahead 72 hours. Note how things have changed, right?
Mhm.
Note how this area,
hmm
right, has shifted, right? More Central Pacific. Note that it's not as angry looking in terms of subsidence. So now you've got, green
Convergence.
showing all above Mexico. And hence, why is there a risk of something developing, right? That's going to be, it makes it favorable on the large scale, at least in terms of vertical motion. We haven't looked at wind shear or moisture, right? Because there's a lot of parameters that go into it. So this is one of the things to take a look at as we go through. That's at 72. So let's go ahead to 126. Now notice how you tend to have, right, large scale divergence to 200 millibars now, shifting even further east. And then as you go through time, that's 5 days. Right now you're up here 180 hours. Right, you see that during that time, now we're at 228, 246, 252. Right. It's the again the tropical cyclogenesis that the GFS is showing, I think, is a function of this larger scale divergence that it is
Yes.
forecasting across pretty much um the waters adjacent to the United States, Central America. Now, whether or not you can get organized convection to develop a tropical cyclone is a different question, right? Because we haven't
Right.
looked at wind shear, we haven't taken a look at mid-level moisture, right? Nothing. We haven't looked at any of those things, and that is all part of it. So this, tells me that what, let's watch and see what the convection does, and see how the areas of convection may propagate across the Pacific, and see what happens. But this is an extremely useful map
hmm
um, to look at when you're looking a couple of weeks down the road, because it was
Yes.
obvious last September when you were looking at this how the whole pattern was going to shift and the lid was going to come off in the Atlantic, and look what happened,
Yeah.
right? I mean, it, it,
Absolutely.
it went to town. It absolutely went to town.
So,
Yeah, that's right when the Blitz started. We had Francine, Helene, then Milton, and then all those other ones out in the Atlantic as well. That was a wild time.
That's right. It's one of those things where you wait all through September and with prime time of hurricane season, and nothing was happening in the Atlantic. I mean, it's about as quiet as one ever sees it. And it's September, and here we had Burl early on, and I don't have an archive of it, but one of the reasons why Burl did what it did out in the Eastern Atlantic is because you were in one of these favorable zones out in here. I remember the Hurricane Center. You go back and look at the archive discussions. That conditions were unusually favorable,
Hmm.
right? And it's because you were in one of these areas, right? But note what happened is it fell apart as it went through not completely, but fell apart. It went through the Caribbean, right? And it made its peak east of the islands and never regained its former self. That wasn't an eye wall replacement cycle thing that you see happen. It
mhm.
was moving into larger scale substance. If you remove the storm from it, this is what it was fighting against,
Right.
which is why it never became a category 4 or 5 again
Right.
once it reached further to the west.
And Dr. Sam, a question that I had too, because I was looking at these maps, and the GFS is consistently pinging at 264 on, like you were saying. It looks like it's hinting at the 200 millibar divergence, which would make sense that that would be a triggering factor. But with it consistently like calling this run after run after run after run after run, could this be a sign that the GFS is hinting that the Central American gyre might be making a return this year? Uh, like kind of like it did, like because we all know what it did last year. It was exceptionally strong. It spat out two monsters that we're never going to forget. And
Hmm.
not saying that it's going to do that again per se, but is there something to this? Is the GFS, because I have seen a lot of meteorologists are talking about the potential return of the gyre again and it having like a significant impact this year. What are your thoughts on that based on the GFS consistently like far reaching out to this signal like time and time again?
Well, we're seeing it, coming out of 206. We'll see if it's right, number one. Right. Number two, is it going to happen again? Is this going to be kind of a if you look at it over time, is it going to be kind of a quasi-permanent pattern as we go through the hurricane season? Right? Is one of the things we're going to have this way, you get it belches out a couple, right? And then then it kind of dies down and then it comes back. That I don't know. That is really tough, really, really tough to tell. I mean, when you take a look across the Atlantic, like right now, and I'm going to stop this. And I don't want to make anybody dizzy. I'm going to pull up another map here. And what I want to point out here are sea surface temperature anomalies across the Atlantic. And we are looking at a different pattern overall from last year. And obviously anything
Mm-hmm.
that's warm is yellow and orange. The blues are where the water is cold, right? One
Right.
of the things I want to point out here is that we do not have an El Nino in the Pacific, right?
Right.
It's not really a La Nina. It's kind of a La Nada, I guess, is what I've heard
Neutral.
people say.
Yeah.
You've got some cool water here, a little warm pocket here, no big deal. And a lot of cold water here off um, the west coast of the United States and Mexico, right? But across the Atlantic itself, right, waters are nowhere near as warm as they were last year in this zone. Now they are still above average because we're still in the warm phase of the Atlantic multi-decadal oscillation. So you'd kind of expect that on the large scale, but they're not as warm as they were last year, which means I think the overall pressure pattern is going to be somewhat different,
Mm-hmm.
and I think that is going to affect where storms form and ultimately where they go. So we may look, when we look back in December at the hurricane season, we may see different tracks than we saw last year, where perhaps it's an East Coast year or something like that. I mean, one of the things that stands out here is the Gulf Stream is not a happy camper these days. It's very right. The
No.
anomalies there. It's very cold. Now, what impact that's going to have, I don't know. I mean, this is all going to change as you go through time, but it's the overall sea surface temperature pattern is very different. So expecting a repeat of last year, right, and how all that, I don't think that's the right way to look at things. I think it's going to
Yeah.
look different.
Gotcha.
How
Yeah,
it's going to
I
look,
think the East
I
Coast.
I don't like to get into the business of, well, you've got a 40% chance of a hurricane hitting
Right.
North
Yeah,
Carolina. I mean that's throwing, I think that's throwing darts at a dartboard
Yes.
to some extent. But when you take a look at the large scale pattern of sea surface temperature in Atlantic, it's different than last year. So you would expect that, the setup is different than it was. So you would expect the season, the manifestation of the season to be different. Right? How that's going to
Mhm.
be different, I don't know, but it is interesting that the waters here in the Eastern Atlantic are cooler. That may be a function of the strength of the semi-permanent high in the Atlantic.
Right.
If that high is stronger, you're going to have. I mean, that's what causes the upwelling here along the coast of Africa. So if that's stronger, you're going to get more upwelling. If you've got, looks like you've got some cold anomalies here along the equator. Perhaps that's due to the South Atlantic high being stronger than average. So, and that would be, I mean, again, you're looking at, well, there's more
Mhm.
mass in the column above each H. And so I don't know. We'll see what that does. We'll see what that does. But I think the important thing is how the MJO, the Madden-Julian oscillation, kind of sets itself
Right.
up and where you're going to get that, um, that
Mhm.
rise in money. Because I mean, last year we all saw the headlines: the waters are boiling, the waters are boiling, and nothing happened in September. And it
Right.
wasn't until you get
Right.
into October, the waters are cooling, and oh, look what happened. I mean, it's so much more than that. Of course, the water temperatures don't boil at 30 degrees Celsius under normal atmospheric pressure, so they weren't boiling;
Right.
they were just above average. But this is
Yeah.
the way you can use language to kind of warp how you look at things. I mean, this is the Atlantic's warm, but it's nowhere near as warm as it was last year.
The Gulf is definitely warm, too. I don't know if you saw, but um, just kind of a testament to the extreme heat content in the far eastern Gulf. Obviously, it's in the shelf waters and not all the way through the Gulf yet.
Oh
But
yeah.
we have the buoys in Tampa Bay are reading 90. I think it was 92 was the data that was pulled the other day, 92 in the bay.
Mhm.
And we had a thunderstorm that formed at about 6 a.m. Yesterday morning, and it took like the perfect path up the mouth of the bay. It formed on that stalled front,
Mhm.
and then it just took like the perfect trajectory up the mouth of the bay, and it hit all of that water. And I mean, next thing you knew, it took everybody by surprise. It was dropping ping pong balls uh, right down the road from where my wife works. I mean, it was just crazy large hailstones for the state of Florida at this time of year, just dropping rocks everywhere. And me and Kate were just discussing how, that heat content in the nearshore waters in the Gulf is super high. Like you said, in the Gulf, or not in the Gulf, the Atlantic, it's nowhere near as warm as as it was last year. I have been kind of taking note, and maybe you could give us your thoughts on this real quick before we go. I've noticed the Gulf seems to be running a little high. I mean, at least to me, from what I'm seeing,
Yeah,
it's running
I
kind
think
of high.
so.
And I've noticed that there's a plume kind of off the coast of Cuba, like maybe like there's an eddy trying to form again. What are your thoughts on that?
Yeah, you can see. Let me see what I can do. Let me zoom in here. But yeah, I mean, you can clearly see that. If you take a look across the entire Atlantic, except for a couple of pockets playing around the Gulf Stream, right? The warmest waters relative to average are in the Gulf and the Western Caribbean, right? And of course, this is surface temperature. It's always better to take a look at, right, when you look at the upper oceanic heat content, because you need this warm water to be through a
Right,
depth, right? Because if it's just surface temperatures, and all of a sudden you've upwelled, right? If you
right,
blow on it hard enough. But yeah, I mean that is setting up, which means that when you have storms, if let's say they form in the Caribbean or they form right in the Gulf of Mexico, right? That helps, right? And, all else being equal, if you have the same magnitude of shear and you've got the same moisture content, if you have a warmer ocean surface temperature, right, then theoretically you should get a stronger storm, all else being equal. Things aren't always equal though, because there's times where you have a storm that's over 26 degrees seawater, and it's wait a minute, how did that get to be a Cat 3? And then you've got something that's over 30 degrees seawater, and it's a strong tropical wave. So again, just to highlight that there's so many factors. But yeah, I mean, you get a lot of times you see these warm eddies that develop in this neck of the woods.
hmm
So, perhaps we'll have to, and it's better to look at a much higher resolution
right,
pictures of
right.
those, right? Because you really get to see, the curls and things of them. You can with the Gulf Stream because it's such a large feature. I mean, you can see,
Pretty
you can
awesome,
see the
yeah.
little eddies and things like that with that.
And
Caleb, did
then
you?
I think I can actually pull up a really good resolution version of that. You were on sea surface anomalies, right?
Yes.
Picking up while you're bringing it up, Caleb, it's pouring outside. Looks like the
Oh, really?
Yeah, it looks like we've already got initiation.
Oh, nice. Let me just curiosity. It's gonna get to me. I just gotta pull up that radar. Oh yeah, it's pouring for you, not for me. I got nothing.
There you go.
So
You can really
last
see
year,
it.
I know the loop current was super strong last year. And when Helene went over, that's when it really exploded. And that's when Josh and I were out that day hunting for outer band
Mhm.
tropical cyclone
Hmm.
supercells. nothing was there. We got that dry air wrapped around, and we could actually see the eye wall tops from like Central Florida when the center of Helene was like down about here. We could see gigantic like 70,000 foot storms.
It's
Oh yeah,
insane.
it's
Like
wild. I mean, there's nothing there. I'll tell you, there's nothing like a looking at convection off in the distance in a purely tropical atmosphere.
Yeah.
just
It's just
second to none.
yeah,
We
it's amazing.
we have this spot where we like to sit. We call it the spine. It's that old ancient shoreline that runs down the center of the state,
Hmm.
kind of down 1727. So we were sitting near 17. I think the elevation is about 200 feet off of sea surface at that point. And with Florida being flat, I mean that's basically like you sitting in a tower. And we were in that clear slot just east of Helene, and just watching that eye wall, just like we're as you were watching the infrared just explode on the GOES scans. Like we were just watching, like it was like Caleb was saying, like you can't put it into words, like just how it was just exploding past the tropopause and just blasting into the lower levels of the
Hmm.
stratosphere. It was incredible to see, and to even see from that distance how clear, how high definition it was.
Right.
Yeah, like this is a view that you usually have to like go through the entire eye wall and get in the clear eye to see, or be in a plane, or see it from space. And we ended up getting really lucky. And then, of course, that dry air increased the mixing, and that's when the winds really started to kick up by the coast. And then then everybody in Tampa figured out that yes, it can flood here.
Well, that's the scary thing. It's
Yeah,
you would have shifted Milton just a few miles further north,
Hmm.
right? And the flooding in the bay. See, and this is why people get complacent because when the warnings go, the warnings go out and they say what the storm surge potential is, right? The key word is potential, right? And as great as the Hurricane Center is, and they are, really second to none, um, until it's a few hours before landfall, um, you know, you can't be accurate within 20 miles, right? Because
Yeah.
the hurricanes they wobble,
right.
just right and things like that. And so, when it's that close, I mean, sure, you could say, well, yeah, it's definitely not going into um Apalachicola, and it's definitely not going into Key West, right? It's somewhere, right? And you get narrow, but it's like, when you're watching it, and I remember watching the radar that night. I mean, it's like, is it going north? Is it going to go right over? Is it going to go just south? And
And they
it's
kept doing like this the whole time, and we're all sitting there watching. And that's what a lot of people don't understand is the way that the bay is set up. 15 miles means the difference between 30 feet of storm surge and 6 feet, and that's what people don't realize. Like that's our reality here in Tampa Bay because it's a funnel.
That's right. That is right. And it's, if you go back to Hurricane Andrew, for example, in 1992, right? It went in 20 miles, 25 miles south of downtown Miami, right? And Miami's barometric pressure was 900, I think at the airport. What did they bottom out at? 990 millibars, and the pressure in the eye was 922. So you're looking at a
That's
seventy millibar
crazy.
pressure difference, right? Over 20. And, you had a gust at the airport, I believe. I think the peak gust was 100 miles an hour. Well, the sustained winds with the storm were 165. You would have shifted that storm 15, 20 miles further north. The damage
Different
to,
story.
right? I mean, it would have been I think beyond imagining the damage to downtown Miami. And I think what folks need to realize is that, you know, we're good at what we do and we're great at what we do sometimes. But 15 miles, 24 hours out, you can't do, right? You might get lucky. And somebody will always be, there's enough forecasts out there that somebody is going to be right.
Hmm.
But here's the zone, right? And a slight shift, a slight tightening. I mean, the eye expands and contracts. If the eye was expanding, right? And for example, if you can have a 15-mile wide eye going in versus a 30. Well,
Hmm.
that shifts where the eyeball is going to be, with even the hurricane moving on the exact
Yeah.
path. So this is why there's always uncertainty, and why people need to heed the warnings, and not be complacent. And especially when it comes, more so than anything, storm surge, because The wind is overemphasized, I think, a lot of times when we hear public dissemination of forecasts.
Yeah.
When you watch the Weather Channel and things like that, the way it is, it's always, people rate it by the wind, and it's the water, right? Right. You run from the water and you hide from the
Right
wind
from the wind.
is
I was going to say
basically
that.
the
Yep.
old
Yep.
thing to say about hurricanes, because it is shocking how quickly that water rises. And it's something that we don't, I can sit on the beach all afternoon sipping hurricane cocktails, watching the tide come in. And it comes up 6 feet in 6 hours because that's what the tide does in North Carolina. For it to come up 6 feet in 6 minutes, it'd be like, my goodness. I mean, you take a look at, I have data on that I show folks from when Irma went over Barbuda, because that was a direct impact. And, the tides in the Caribbean vary hardly anything. It doesn't do, right? And in an hour, the water level rose 8 feet. Right, that's a
Good Lord.
one-story building of water, right? And it's extraordinary when you think about it.
Or the one thing that blows my mind, Dorian sitting over Grabico
Mm.
Island, and there's a
Mhm.
satellite image, and not one, like when the eye went over the island, and there's not one building that is not completely submerged by salt water. It's like, to me, it blows my mind how anybody on that island survived. Obviously, they did, and they did a remarkably good job. But just seeing that image, I'm like, how I remember because I was in a classroom and I had a bunch of kids whose families lived out in the Caribbean, so they were always coming to me. They were always asking, where's it at? What's the update? I can't, how's my family doing? And I remember looking at that image and seeing everything was underwater, and I'm like, how is anyone even alive?
And yeah,
It's amazing.
it's amazing. But if you're up high enough and you're far enough from the coast, because the storm surge only goes so far inland, and we look
Right.
at these maps and it looks like the island is just a line. It must be completely underwater, and it's not. I mean, it's when you take a look at the slosh model that the Hurricane
Hmm.
Center, right,
Right.
maintains, right? The sea land, sea lake and overland surges from hurricanes, and you see how far in, even in the worst case scenario, the worst case scenarios, how far inland it penetrates. It's only a few miles. I mean, some
Yeah.
places that are flat and marshy, it's further than that, but you don't have to evacuate far to not drown,
Yeah.
Oh, I
right?
think the
And
general
it's
rule of thumb for most areas, correct me if I'm wrong, Dr. Sam, but it's like, I think that I was told 10 miles as a general rule of thumb for
Yeah,
the surge.
and sometimes even less than that, depending upon, depending if there's rivers and things like that nearby. But yeah,
Hmm.
I mean, a lot of places you go off the barrier islands
Hmm.
and you're going to be okay
Yeah.
from the
Right.
storm surge. Now the wind may get you, but that's the whole thing is the people that ride out storms on barrier islands. Um, I mean, it's while it may be a meteorologist's dream to do that, it is the most dangerous thing in the world you could ever do. And if you're
Yes.
just a right, and so this is why you have to evacuate people and get them off, because you go 10 miles, you're not going to drown from the storm surge. Right now, you have to worry about
Right.
inland flooding. That's a different beast.
Hmm.
Yes.
But you're all you
Absolutely.
gonna do is be in a safe shelter that's up high, and you're gonna be okay. But
Yeah.
hey, let's go surfing in a Cat 4.
Yeah.
No, no. There's easier ways to get yourself on television than
No,
that.
and I can tell you, there's this in regards to that. Me and one of the other local meteorologists here in the area that me and Caleb know, me and him were we were at Madeira Beach. I don't know if you know where Madeira Beach is in Pinellas County, right near the tip of
Not
Pinellas.
specifically, but I've heard of it. Yeah.
It's right near the tip of Pinellas County. And when Tropical Storm Column was coming through, I think that was 2015, give or take a few years. So it was a while back, and it was only a 50 mile an hour tropical storm. But I mean, once we got on the beach, it was really ramping up. We were getting gusts to about 70. It was starting to, like, you could hear it stripping the gears and the fans of the beach
Hmm.
houses and all of that. The water was rising quick, but there was parasailers out there, parasurfers from Australia. There was a whole pack of them, and they got caught. And they were just like, so they're strapped to those surfboards, holding those big parachutes. I mean, just being drugged through the sand. And so what we were having to do is stand on the beach, and as they came flying on the beach, first person would grab them in a bear hug, second one would pile onto him, and we were having to form Indian chains to stop them. We ended up
Hmm.
stopping. We ended up catching like 4 of the parasailers like that. We catch one, bring him down, and then the next thing you know, here comes another one being drugged through the sand. So everybody had to catch him,
Wow.
jump on top of him, and it's like you're saying, people just don't they don't think.
Yeah, I mean, it's listen, I did run down to the beach during Hurricane Irene back in 2011. Um, and got some great pictures. But when you see the ocean and you realize that water is 1,000 times more dense than air, right? The thought
Hmm.
of actually doing anything, like I mean, I actually didn't go down onto the beach because it really wasn't a beach because the waves were crashing into the
Right,
dunes. Right. I'm like, geez, if I fall down these stairs, I'm going to get swept away.
right.
And it doesn't look like it's as powerful as it really is, but just try walking. Go to a water park and try walking through like a wade pool for a while. And it's amazing how fast your legs start to tire. And that's with water that's not moving. And you just don't realize the power of it.
I mean,
And people misunderestimate it.
just going to the beach on a regular day, because I mean, we're at Melbourne Beach a couple weeks ago. Weather's great, not really much wind, but just because of the fetch across the Atlantic Ocean, I mean, that current. I mean, we were standing out in the current at about our waist, and just the force that those waves try to pull you back in on a day when there's no wind,
Mhm.
let alone a hurricane when everything's clawing at you and trying to rip you out with it.
Oh, absolutely.
You're you're gonna lose every time.
Yeah, that's right. You do lose every time.
One thing that amazed me about Helene, and when you sent me the storm surge model that you created, Dr. Perugini, um, it's crazy how it matched up. The up the river, we have the Alafia River. It feeds right into Tampa Bay. It's got real wide mouth, and then as it goes inland, it narrows to the point of where like
Where
you
I'm
can't
at.
even put a canoe in it really.
Right.
That's where
And
I'm at. I'm at the headwaters.
yeah, like where he is, you could walk across it. Where I am, you would be
Yeah.
swimming. But the amount of flooding that went up that river,
Just
the place I work at right now is a little bar that's right on the river. Our actual building is about 7, 8 feet above that. The water was up to the top of the bar in that building, and it was encroaching on the houses next door. Like there's a whole neighborhood just down the road from there that's just poorly planned, really, because it almost looks artificial. It goes down from the street, and then it's like got this big winding street that's down there, and this cul-de-sac. Every one of those homes flooded out.
Hmm.
You hear from people just how like horrible that is, and they really that was the luckiest way we could have flooded in this area because it
oh
was
yeah.
a 7, 8 foot surge, but it was more gentle. Like the winds that were driving this were maybe 40, 50, 60 in gusts, but sustained. It wasn't too crazy. So it was just this big rise that happened over the course of like an hour and a half. And then once that wind shifted just a little bit more southerly, it just
Right.
dropped off immediately. But then you look at Pinellas County and right on the beaches, like homes were getting bashed in. There's still a ton of homes out here
They're just
that
abandoned.
yeah, they're just caved in at this point and left to rot essentially. Um, but yeah, you shift Milton to making a landfall at like Indian Rocks Beach, and you would have had homes floating in the waves at that point.
Oh, absolutely.
It just blows me away for even besides the surge. I know we're getting way off topic and stretching long here, but it just blows me away how much water Milton dumped. Like I said earlier, I live at the headwaters of the Alafia, so you can literally walk across the river most days. And the bridge, there's a big bridge down the road from where we're at, very very high bridge, and all the hurricanes we've been through, Francis, Gene, uh, Irma, Ian, like all the big names, all the water that came with it, all of the crazy flooding that came with Irma, never, ever had water top that bridge, ever.
Hmm.
The morning after Milton, and me and my dad went down to check on the family, and we did not cross that bridge because when we got to that bridge, We don't have a monitoring station there, but I wish we did because that water had risen probably 20, 25 feet and was touching the bottom of that bridge at the headwaters. I was like my head, I took a picture of it because I have never, ever, ever seen water that high
That's
there.
right. Yeah, it's amazing. And I'll tell you, hurricanes that are becoming mid-latitude cyclones, right? When they're doing that transition to
Yes,
post-tropical, and they've got
yes,
you basically, meteorologically is not the right way to say it, but I think you get what I mean is you have on one side a hurricane and on the other side you got a mid-latitude cyclone where
yes.
you've got increasing temperature gradients and things like that because you're moving from a barotropic to a baroclinic environment within the storm. It really ramps up the precipitation process. Because it enhances gradients, this is why you get these strong winds
Hmm.
on the side of the storm that you wouldn't expect them to be. And again,
Hmm.
what you would expect them to
Yeah,
be is when you go textbook, it's a purely tropical system. It's a barotropic. It's moving, east to west, like an Andrew was or something like it's a classic. That's right, and it's small and everything like that. But yet you have these mid-latitude interactions, and the wind field expands, the rain expands, and you get tremendous rainfall amounts because you've got other processes that are going on that are not there in a purely tropical system.
right. And like you were saying, the strongest winds were not where they were supposed to be with that one. It was
No.
it after the eye passes was when the wind got absolutely just staggering. And it was, I've never seen that kind of wind before.
Right.
I
It's when I went through Gloria in '85. I was living in Philadelphia. That's where I grew up. It was the same thing. We got, we were on the west side of the storm, which is the rain side of an East Coast hurricane, just because, you
Hmm.
basically had, the cooler and drier land versus the warm, humid. It got a great overrunning surface. You got all this rain. After the center passes and the rain stops, is when we got our strongest winds.
hmm
Right? And it's
yeah,
not, we when you look at textbook hurricanes and what you hear, oh, you've got the strong winds and everything like that, out ahead of the storm. Well, it was actually behind it, and it's I don't care what type of a system it is. Wind is produced by the gradient,
the
right? By the
gradient.
pressure gradient, and when you have a completely symmetric storm in the tropics, this is what it generally looks like in terms of where the wind is the strongest, and you take your pick of which way it's moving. When you've got something interacting with the mid latitudes, the pressure gradient gets disrupted because now you've added temperature, and a temperature gradient is effectively a pressure gradient, right? Thank you, ideal gas law. And so therefore, right, and it is. See, there's thermo
Yes,
coming back, right?
yes.
Yeah. See, this is why we do thermo, and so where you find these strong winds, right? Because it's
Hmm.
is what happens. And plus, if you're
And
getting connections to the mid levels of the atmosphere where you're getting momentum mixed
yeah,
down and so forth,
and you could
it's
tell because I mean, when what the temperature, what did I say it fell to, Caleb? Like 62, which never
Yeah,
happens in a
it got
category 3.
chilly.
It got so cold, I was shivering on that porch because that temperature plunged because it was like when Mill started moving in, it was that warm, rich, moist
Like
tropical environment. It was like
75.
75, 76. And when the back end wrapped around, when that sting jet kicked in, or pseudo sting jet, whatever you want to call it, I mean, you could feel it felt like ice. Like when that wind started mixing in, right when I told you it was kind of like we saw the rain start blowing straight down instead of sideways, the
right.
temperature plunged. And um, unfortunately, we don't have very many established wind gauges in the area. I wish we did because we're kind of in that gap. The worst winds that hit in the county is in that gap where we don't have any kind of wind gauges that are approved by the National Weather Service. There were some tempest gauges that backed up the theory that wind gusted to 130, and there was a couple professionals that were in the area that backed up the claim too and said that they saw the same. But I mean, just there was a path of damage, and Caleb saw it from about 10 miles to my west to just to my east. That I mean, straight looks like it was involved in a bombing run. I have never seen that
Hmm.
much destruction here, and it was in a specific like a swath
Right.
Yeah.
of
Like we
hyper
were losing
concentrated,
palm trees down here. Like
yeah,
new homes getting all their shingles stripped.
stripped off like brand new construction
They
getting
should have had the
stripped bare.
shingles vaccine. That wouldn't have happened. And I'm bummed.
Yeah,
But yeah, that was a wild storm. I guarantee if the west coast of Florida sees another like a Milton repeat this year, there's going to be a mass exodus.
I mean, there already
Well, yeah,
was.
that's what happens, and that's what it takes. People get scared by something like that. I mean,
Yeah,
listen, when we saw it down there, sub 900, one of only a handful, that scares people. Now, it was never forecast to be that intensity when it made landfall, right? The forecast for it to be weakening um, was spot on.
But I
No,
will
it
tell
was
you this:
absolutely spot on.
when I woke up that morning, though, and it was
oh
showing
yeah.
a Category 5 at 160-mile-an-hour wind still, and it hadn't started that weakening trend,
Hmm.
I gave my dad a phone call. I was like, "Dad, you see this? It still hasn't started weakening yet." Because when it's running like Milton was. I mean, Milton was a runaway train. When it was doing that, I was sitting there. I'm gonna be honest with you. I was sitting there. I was looking at it. I was like, "Man, they're saying it's supposed to be weakening, but I'm not seeing it." I mean, eventually the dry air intrusion started, and it did unravel a little fat. They had anticipated it to start earlier. Instead, it ended up being shorter and quicker, but still hit the same
Right.
intensity threshold that they thought. But man, I was starting to sweat that morning when it was still a Category 5 at 160, and I'm like,
That's
"This is
right. You
coming
go through
right
two,
for me."
3 hours where, oh, it's not doing it. It's not doing it. And you're like, are we going to get hit by a five? And then it starts
That's
leaking like,
yeah.
okay.
I mean, and that's literally because I was sitting there, and because my goddaughter lives in Apollo Beach, like on the water, and I gave her a phone call, and I said, "Get out! Like I don't care. Make your mom get out." There's no you're maybe going to. There's no you're might like you're getting out one way. And thankfully they listened, and thankfully the wind it came in just south, so they didn't get flooded out. But goodness gracious, that storm it was a marvel from the meteorological perspective and the scientific perspective. I ate all of that up, but considering the people I had that were in the path of that,
Well, that's right. It's
oh
and
man,
the thing is that the weakening storm, the quote unquote weakening storm, actually is a bigger danger than the Cat 5, in my opinion. Because what happens with these things is when they begin to weaken, their wind field expands
right,
so that more people get affected. Now, the area that's going to get the Cat 5 winds is so small, right? It's
Yeah.
it's so tiny. But the areas that are getting the non-Cat 5 winds are getting hurricane force winds, right? Which is the majority of the envelope of the right that expands. So it ends up, I think, doing worse, even though the actual maximum wind goes down. I think it can end up doing more damage that way because it's spread out over a larger area as opposed to it being more concentrated.
well,
Yeah.
also, okay, so you've kind of segued into something I was wanting to do later, but since we're on the subject, you might as well cover it now. Dr. Sam, what are your thoughts? So, obviously, we were talking about that kind of that sting jet that wrapped around when that dry air wrapped around Milton right as it began that extratropical transition after it made landfall and it mixed those 500 millibar winds to the surface. Um, like you were saying, sometimes it does more damage when that wind field expands, because it's like you're not getting the sustained 130, but you have that potential at that point. Correct me if I'm wrong, to get 130 gusts at a much wider area because now you've got that mid level mixing to the surface in these rain bands, and it starts getting those streaks of damage. Correct me if I'm wrong, but isn't that kind of like what we're looking at that
Well,
point? Because it's mixing.
that's exactly right. Which is right. It's because if you're doing a strong wind over a much larger area, there's more things to destroy. Right. This is
Right.
why it's always misleading when you hear hurricanes do more damage now than ever. Right. And they try to attribute it to X, Y, Z. Well, they do more
Right.
damage because there's more things to destroy. Right. If you take a look at it, but we just had a presidential election, right? What's Florida now? Like 32 electoral votes or something like that. In
Yeah.
1960, it was seven. Right? It was so sparsely
Mhm.
populated that the hurricanes that hit Florida in the 40s and 50s and into the 1960s, there was so much less population, so
Right.
much less damage that could have been done because it was so sparsely populated relative to the rest of the country, that is, right? And
Right.
now you take a look at how much there is. Yeah, I mean it doesn't take much, right? The same storm now. You take a Hurricane Donna in 1960 and you do the same storm now. The same storm now is going to do more damage because there's just
There's
more
just
in
higher
its path.
population. Yeah,
Yeah.
I was reading somewhere they were talking about how it was somewhere along the lines of the $1 billion storm is here to stay, basically, because we've moved so many people. Actually, you know what? No, because it was in one of my classes last year. Uh, it was Dr. Haney. She was bringing up the point. 40% of the population now lives on the coast in strike range, and it's like,
Oh,
like almost it's and she brought up that point, and I don't think this was in her lecture. I think I read this somewhere else, but it was like with all of these people just congregating and flocking to the coast, the $1 billion disaster is here to stay because it's gonna be hard to find a sparsely populated coastline for a storm to hit now. Everywhere it hits, you're running into condos, you're running into neighborhoods, you're running into subdivisions, and then you've got the whole subject of them pumping water, for wells, and then the land sinks, and that just exaggerates things worse. And you
Well,
know,
plus property values, right? For example, the Outer Banks,
yeah,
North Carolina, in the late 1970s, you could buy a, you know, beachfront home, right? 4 bedrooms, other, right? Which was a massive house for the for $25,000. Today, the same
wow.
homes go for 3, 4 million. Same house, right? So yeah, same storm now. 1978 would have cost $25,000, but now it's 3 million per house. I
it's
mean,
wild,
it's like, yeah, imagine and it's not monopoly money, right? And this is
right?
how much it costs to build hotels in the game Monopoly, right? If they adjusted that for inflation, I mean, how much money you walk out. But I mean, that's all
Yeah,
part of why you have to be careful with those types of numbers. Yeah, it is here to stay for a lot of reasons, where there's more
right,
people and plus things are more expensive.
true, yeah,
Yeah.
right.
I mean, I used
It's
to
just,
go to McDonald's and be able to get a hamburger and a small fry for 84 cents when I was a kid,
Oh,
right?
you gotta be kidding me. Oh my
You
God.
can't even use the bathroom for 84 cents at McDonald's these
No.
days, right? So
maybe
it's
I'm giving away my
You get a
age,
water
but
cup for 84 cents.
I remember the dollar menu when you could get the single hamburgers for 50 cents. Maybe I'm telling
hmm
on myself there.
Oh
All
yeah.
right,
But
well, we are now. The time has ran away from us, and we're at an hour. This is
oh
gonna be
my
a
God.
nice long
Well, I guess it's
upload. But
time to run for the hurricane evacuation route.
yes, Dr. Sam, thank you so much for spending the evening talking to us. For those of you who have stuck with this viewing, um, Dr. Sam will be visiting us again later on in the season, and um, we may be fortunate to stag him a couple times if we do get some big storms in the vicinity, so he can break things down for us real time, so that you guys can see uh, a breakdown from a professional perspective, someone who's an expert in the field. So as these storms are moving across the Gulf, the Atlantic, whatever, we'll have someone who's an absolute expert in the field breaking it down for you, so you guys can get a better understanding of what's going on. Caleb, you have anything you want to add to this before we shut things down?
Um, no. It's gonna be a good year, guys.
It's going to be a fun hurricane season. Buckle up.
Definitely is. All right, guys. Florida Man is out.